video we're going to look at the rate of reaction, and we're specifically going to look at factors that affect the rate of reaction, putting an emphasis on temperature, concentration, particle size and the nature of the reactants. So our learning intention is to study the effect of particle size, temperature, concentration and nature of reactants on the rate of a reaction. So there's 5 factors that affect the rate of a reaction, and they are the nature of reactants, the particle size, the concentration, the temperature, and catalysts. And in this video, we're going to look at numbers 1 to 4 here. So the first factor that we're going to look at is the nature of reactants. And when we're looking at nature of reactants, we're simply talking about how our particles or our reactants exist for the reaction. So reactions that involve oppositely charged species coming together are usually fast at room temperature. And an example of this would be a silver ion and a chlorine ion coming together to form a precipitate of silver chloride. Reactions involving the breaking of covalent bonds are usually slow at room temperature, as it takes time to break the bonds. And an example of this slow reaction is the reaction of ethanol, which is covalent, and acidified sodium dichromate, which is ionic. So the next factor that we're going to look at is particle size. And to summarise, the smaller the particle size, the faster the reaction. So if we take a look at a specific example of this, we can see that large marble chips in 50 centimetres cubed of hydrochloric acid will take longer to react than small marble chips in 50 centimetres cubed. So here we can see that the large marble chips, the amount of product formed is a lot slower, so the slope of the graph here isn't as steep as when we have the small marble chips. And we can also see that the reaction comes to completion earlier with the small marble chips. Now, the main reason for this is due to an increased surface area. So when we say increased surface area, that means that there is more surface for the hydrochloric acid to react with the marble chips. So if I was to draw this for you in a diagram format, we would see here that if I had one marble chip versus a marble chip that has been split in half, we can see that the HCl will only be able to react with the outer part of your marble chip, but when the marble chip is broken down into 2 smaller parts, there is more surface area for the hydrochloric acid to react with. So the third factor that we're going to look at is concentration and how it affects the rate of the reaction. So changing the concentration of reactants in a chemical reaction alters the rate. And let's look at a graph to show this. So if I have magnesium in 50 centimetres cubed of 1 molar hydrochloric acid, it will react quicker than magnesium in 50 centimetres cubed of 0.5 molar hydrochloric acid. So that would indicate to me that the higher the concentration, the faster the reaction. So here we can clearly see that our 1 molar hydrochloric acid and magnesium reaction has a much steeper slope and finishes at an earlier point than the 0.5 molar hydrochloric acid. So that indicates that increased concentration will increase the rate of the reaction. The last factor that we'll look at is temperature, and as we would expect, similar to our concentration, the higher the temperature, the quicker the reaction takes place. So an example of this is placing a solution of sodium thiosulfate and dilute hydrochloric acid, mixing them together and placing them on top of a sheet of paper with a red X. The hotter solution will react quicker and the red X will disappear quicker as a result due to the formation of a milky precipitate in our solution. And we will look at this in greater detail in a later video. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.